All right, so share screen. Let me close my door 1 second. Okay, so let's kind of get caught up with where we are. We did this, so got those videos up. And I believe the last thing that we did was this second getting started with Unity video where we looked at lerping the camera, correct? Okay, so we lerped the camera last time, and lerp is important for smoothing things out and that sort of thing. And I also uploaded the sample prototype of the color box, which we talked about. So this is a complete project that you can check out in Unity for some examples on how to do things. Let's look briefly at your assignments. So this is what we have coming up. Is tomorrow night you have this due. What makes a good game? So here's the way this works. Let's run through this, make sure you guys know exactly what you need. And I try to time these homework assignments so that they coincide with what you guys are doing with your games. And I try to make sure that these homework assignments get you thinking about the right things that you need to be thinking about for your game. So let's kind of walk through what these are, or what you need to do. So instructions, you're going to research a game design principle. All right, and there are hundreds of game design principles. We have talked about a couple of them in the class, but I give you some links to some examples if you want to pick one of those. Okay, they do need to be an official principle, not something that you just kind of created in your brain. Now, whether or not something is official depends on whether or not it has been officially recognized by somebody. So if you find an article online, or there's lots of books on game design principles, or you can use one of these two links, either of those is fine. The point is there are hundreds and hundreds of game design principles. Pick one. Okay. I want you to explain what the principle is and how it affects a game. And this can be a good way that it affects the game. So if you do this principle well, it can affect the game positively. If you don't do this particular principle, or it's implemented poorly, it can negatively affect the game. Those are the kind of things that I want you to talk about. And submit it right here through Canvas, and that's it. All right, we have some questions in chat. So just to be clear, color box would not be an acceptable submission by the end of the semester. If you mean turning in the game that is already completed, no. But if you mean would that scope of a game be good, then yes. If that makes sense. So you can't turn in color box as your own because I know you didn't make it. But if you made a game like it in the same sense of scope and that sort of thing, then yes, that would be fine. Did that answer your question, Mitchell? Okay. What's MDA count as a game design principle?
By that I mean like the framework of like mechanics, dynamics, and aesthetics. We learned about that in intro to game design. Would that be a design principle, or is that just
No,
something
not
that's
really.
done? Okay.
Design principles are more focused. So you like we can click on this. Here's 7 game design principles. So you should have objectives.
Hmm.
You should have reward. Not should, but these are things that you should consider in your game. Another one is affordance. Affordance is the idea that when you look at something in the game, you automatically know how to interact with that object because of that object's design. And so
So you just choose one then and talk about it. Thanks.
that's right. You're only going to pick one. So
Okay.
affordance is like this. We see this object in front of us. Based off of its design, we know how to interact with it. So I'm going to go like this. Okay. Or I can stick my finger through here. This design gives us an idea of how to use it. Okay. And this is all the kind like we see these things on the side. The fact that they are colored differently, the fact that they are raised indicates, ooh, push me. If we walk up to a door and the door has a flat metal plate on it, no doorknob, no handle, it just has a flat metal plate. What do you do with that door?
Push it.
Push it. That's right.
Push.
You wouldn't grab a hold of it, and that'd be pretty silly trying to get your hand to like pull the door. And so that's the idea of affordance. The design of something tells you how to interact with it. If you walk up to a door and it's got a long handle for you to grab, how do you open that door? Pull it. That's right. You're going to pull it. And so that is the idea that you should do in games. Like the objects, the interface objects should be designed in a way that indicates to the user how they should interact with them. Okay. If you've ever seen somebody like play a game on the phone and they're like tapping and swiping and doing all kind of stuff, and they're like, what am I doing here? That game has really bad affordance. You should be able to look at something and know how to interact with it based off of the design. So if you have a button and the button is beveled a little bit, or maybe it's colored slightly different, that gives you an indicator, oh, this section of the UI is different. I should click it, that sort of thing. So that all is the game design principle called affordance, which means the items in your game that the user can interact with should be designed in a way that makes it obvious how the user should interact with them. Okay, so
Okay.
you pick one game design principle. There are literally hundreds. Like be kind to your player. Don't intentionally do things that annoy the player. Just like there are writing principles, like things like you should never lie to your reader. You should never lie to the person you're playing the game. And so there's a lot of that sort of thing. Pick one and discuss it.
Thank you, Professor.
You're welcome. A couple other ones from chat. Unity question for after we talk. We'll get to that in just a second. Susie, yes, give examples.
Oh, we can't give examples?
Yeah, you should
Oh, we
give
do.
examples.
Oh, thanks.
Yes, sir. Brian, I talked about how a design principle is used in the game industry during the development process and within a game, but I didn't mention the consequence negative aspects. That's still acceptable. Did you talk about how it affects a game? If you talked about how it affects a game, that's fine. The consequences are just one way in which it affects the game. If you didn't talk about how it affects the game, just resubmit it. Just add that and resubmit. Questions on this assignment before we move on? So if you guys have already turned this in, you can resubmit it. I believe I allow for resubmissions. Let me double check. Yeah. just re-upload if you need to. No, you don't need to include research papers. There aren't going to be a lot of research papers on this sort of stuff. Double spacing is fine. Yeah, I believe it says if you typed one page, double space is fine. Any other questions? Okay, let me get to the Unity question up here. I was following some tutorials for third-person camera controller, and some used smooth damp instead of lerp slurp. Is there a significant difference? No. The smooth dampening, it's going to use a different method for moving the camera. You have to keep in mind there's lots of different ways to do things in Unity. And if you are manually moving the transform of something, or the position of the transform, that's where lerp and slurp is going to come into play. If you're using another method for moving stuff, that's where you get you can use dampening effects for that sort of thing. But generally speaking, if somebody is putting out one of these tutorial videos on how to do something, you can tell pretty quickly just by the quality of the production of the videos and the quality of the audio, whether or not they know what they're talking about. As always, if something's on the internet, just be a little cautious. And I strongly suggest you check the date when you're watching these things. Unity has changed a good bit over the years, and it's been out for a long time. And so I wouldn't suggest following a tutorial from 2016 because you're going to get a lot of outdated stuff. So try to find something new. Unity themselves, they put out a lot of content. So check that out too. I mean, I look at YouTube, not so much anymore, but when I was first learning, I learned a lot from it. So definitely there's a lot of good content out there. I've also seen a lot of people do stupid things with Unity. The good news is you can get away with a lot of stupid things, especially in these games that you guys are doing. So side note, soapbox, don't stress about doing things the absolute best perfect way. You haven't been doing this long enough to worry about that. One of the things that made me successful in what I have done in the games industry is that if something works, I don't stress about it being the best way to get it done. That has allowed me to actually finish things and get them out there and improve on that in the future. That is my advice to you. Don't stress about making sure something is the most optimized or the absolute best way to do it. Just if it's obviously affecting your game, then yes, find a better way to do it. But if it works, let it go and move on to something else. Okay, I have optimized my code over years and years and years and years, and I didn't start out being awesome at it. And now is not the time for you to spend a bunch of time doing that. Get your game done, then go back and if you have time, fix it. That's my piece of advice for you. Okay, questions on that?
I know you said you haven't used YouTube in a while, but any off the top of your head, are there any other besides the Unity YouTube channel? Is there anybody else that could be helpful? I know Code Monkey is one that I've used. There's a couple ones, but do you have any like recommendations off the top of your head? And no,
not off the top of my head. I kind of do one-off type things. Like last year, I switched Access Football from using the standard rendering pipeline, which was the old camera and lighting system to the new version, which is the universal render pipeline. There's also an HDRP, but I didn't use that one. And I looked up a handful of different tutorials and setups, people doing it, and I kind of cross-referenced them. So like, okay, this person's doing this, and I looked for consistencies before kind of doing it on my own. So Google is your friend, and just use some discretion with regard to what information you're following. Just make sure it seems like they know what they're talking about. And you can kind of skip to the end of their videos to see if they're actually producing something that is somewhat intelligent. But I don't have any specific recommendations now.
Okay. Well, thank you. That's helpful.
Cool. Yeah, and you're welcome to post on the Canvas page if you find some good stuff. Or I think you guys might have a Discord. That's fine. All right. Any other questions before we dive into what we're going to do today? Okay. So we've gone through kind of getting started with Unity. This representing a 3D environment. We've looked at some of this stuff already. I'm gonna just I want to go through this briefly. We talked about LERP already. I guess we've done this already. We go back to modules. Here are, this also coincides with your homework. If you want to look at some game design principles, we talked about affordance, Buster principle, cognitive bias. You can kind of go through here. Synergy is another game design principle. You can go through here and get some of those. Okay. That brings us to where we are today, which is position and rotation manipulation. And these are kind of the last parts before we get into kind of topic specific stuff with Unity. And we're getting to the part in the semester where I'm going to give you more time to work on your games. And so what I'm thinking is starting next week, Tuesdays, we will meet to cover some Unity content. So we'll go over, that's where we'll cover like cameras and lighting and models and animation and that sort of stuff. But what I think you guys really are going to benefit the most from is just time to work on your games. And so we'll maybe meet Tuesdays, and then I'll give you Thursdays off to work on your games, but be available if you guys need anything or have questions. But since today is Thursday, we'll cover position manipulation. We'll get through some of this. This is basically how to do vector math and why it's useful inside of Unity. And then Tuesday, we'll do the same thing. We'll continue with this, and then I'll give you Thursdays off from there. Thoughts on that? Or do you want more content? You tell me.
I like that.
Okay.
Yeah, sounds good to me.
Okay. Yeah, Thursday would be kind of like open office hours type thing. And what I can do is I'll just like, if you have some questions, just shoot me an email and we can plan to meet during that time. Otherwise, you guys just use that time to work on your games. I think that that will be most beneficial for you, because there's only so much you're going to learn from me talking about this stuff and showing you stuff. You've got to just get in there and mess with it yourself for you to learn it. So we'll plan on doing that. Okay. So let us talk about position manipulation today. All right, so we talked about before the idea that every game object in Unity has a transform component. Okay, transform components have three things: position, rotation, and scale. So let me pull out here. I've got Unity open. Every game object has a transform component. Transform has position, rotation, and scale. Okay. We're going to look a little bit more specific today about the position vector. So, need to understand how to add and subtract vectors, because this is going to be pretty important. So, have you guys done vector math? Just basic stuff, adding, subtracting. If so, what class do you do that? Physics?
Linear algebra, I
Okay.
believe. It's been a
Yeah,
while.
I think one of the algebra classes, some math class.
Okay.
I'm doing that in my robotics class. It's kind of a lot.
Well, this will be more basic, but some of the same principles apply. Okay. So the idea in Unity is vectors are points. They're also lines, which is confusing. When you're talking about the position of something, it is a vector 3, and that is a point in space. If you have 2 points in space and you add them together, think of it like taking a series of steps from one to the next, okay? So we have point A, which is at 3, 5, and point B, which is at, or point, excuse me, coughing. Point B, which is 2, -1. You add them together, and it's like you're literally walking along those lines. So 3, 5 plus 2, -1 ends you up at 5, 4. Right. So that's how vector math works. If you know, let me actually pull up the sample project that we've been working on. So there, Colin just put something in chat. So a phenomenal YouTube channel for basic linear algebra and theory is 3 blue, 1 brown.
Really good visualization of like what we're talking about.
Well, definitely go check that out. They'll probably explain it much better than I. All right, so quick review. This is what we did last time with this. All right, so we move, and the camera lerps to us. Okay. What we have, or what we're going to do here, is some position manipulation today. So let me pull this back up. And okay, so when you add 2 vectors, it's like you walk to the first and then walk to the second. And then where you end up is the result of the addition. Okay. So take a look at this. Given the following piece of code, how would you find the position that is 5 units above and 3 units to the right of the supplied game object? Okay, and this is the answer. So you have the ball, and you want to get the new position. You're simply going to add on a new vector 3, 3 being the x, 5 being the y. Okay, notice it says 3 units above. The z, which is the depth, stays 0. Okay, so if we were going to do something like this in code, it would look like this. All right, so we've got our player here, and we're going to add a new, so just right-clicked and we'll go create, or we'll do 3D object. We'll do a cube. Okay, we'll move our cube up into our world, and what we'll do is we'll call this bad guy. Right, click right here, go reset, and then we're going to move him up 0.5, just like we did the player. Okay, which way is forward? Okay, so take our bad guy, and what we're going to do, we're going to create a new script. We'll leave our bad guy to solid white. Well, actually, let me do this. We go to ground texture, open this up. I'm just going to go solid white. And I'm just going to call it solid white. Yeah, so now we have white texture. And then on the bad guy, I'm going to drag and drop a new material. So create material, and we'll call this bad guy material. Okay, and then I'm going to drag and drop this white here, and then we're going to tint it. What color should our bad guy be? Red. Okay. We'll make it red. All right, so then we'll take our bad guy. We're going to drag and drop the bad guy material. And now he's red. Cool. Okay. Then let's add a bad guy manager script. Create an add. We'll let it pile, drag and drop it into our scripts. Okay. And we've got our bad guy right here. Let me open up this code. All right, so the first thing that we need to get access to this bad guy's transform. Yeah, so we'll call it trans. Save it, come back here. And we're going to drag and drop right here to assign the transform component to the script. Okay, so now we have access to the transform component of our bad guy. All right, now we'll say private void start. I know I just deleted it, but I didn't like where they put the braces. I had to fix it. And what I want to do is, just like it talks about here, I want to put the ball in a specific position. All right, so what we can do is we want to get let's have it start in front of the player. But this leads us to a little bit of a problem. We can change inside, because we're inside of the bad guy manager script. We can change the position of the bad guy, but we can't do it in reference to where the player is. Okay, because the player right now is managed by its own script, and we don't have access to the player script here. All right. And so the bad guy manager cannot interact with the player manager and vice versa. And this is important because you guys are going to run into this. There are a couple of different ways to handle this problem. We could create a reference from the bad guy manager to the player and from the player to the bad guy. That's one way to do it. The downside to that is if you have a bunch of bad guys and a bunch of players or a bunch of things, then you need a ton of references going back and forth, and that's not the best way to do it. Another way to do it is by creating singletons, which isn't a bad way. I'm going to show you kind of an easier way. There's lots of different ways to do it. I'm going to show you kind of an easy way, and that is to create a game manager that we will kind of like a static, or you could turn this into a singleton. Let me show you how that works. All right, so we're going to go create empty. So an empty game object just has a transform. It's different from one that has renderers and actually shows up and it's just game object. And I'm going to call this game manager. And then on here, we're going to add a game manager script. Okay, create and add. Now, whenever you have for whatever reason, game manager is like a specific term from Unity and it changes the changes the symbol here. All right, Nick said, when I was doing research, I saw a lot of people saying that singletons were problematic. Singletons can be problematic. They can also solve a lot of problems. Singletons are a design pattern. And like many design patterns, there are pros and cons to them. The downside to using singletons is it creates dependency issues. If you are going from one scene to the next, you need to make sure your singletons are transferred to there. They're not blanket statement bad or good. I use them all the time in Access Football, but I understand their limitations. And so if your game has a ton of scenes, singletons can be a little bit of a, they can be a little bit cumbersome to make sure that every one of your scenes has all of the singletons that you need. I like them. You're going to find people that say they don't like them. That's fine. I understand the downsides to them. I don't think they're the most amazing thing ever, but I think they fix a lot of problems, especially for beginning game developers. The alternative to singletons are generally really complicated. They involve things like scriptable objects that require a mental architecture that is difficult for beginners to maintain. So take that for what it's worth. If you want my advice, start off with singletons, but know that they're not a solution for everything. So with that said, let me talk about what singletons are. Singletons are, they are a design pattern, and the singleton design pattern forces a single instance of something to exist throughout the duration of the program. It doesn't allow multiple instances of a class to be created, hence singleton. And because you are forcing a single instance to exist, you can reference that instance statically. Is that an adverb, statically? It is now. You can access it in a static fashion, which makes keeping references between things much more simple. So what I'm going to do is I'm going to create a singleton out of our game manager script, and you're going to kind of see how this works. All right. So let's create a singleton. We're going to say public static game manager instance. Okay. Now, notice what I've done here. One, it's public. We need to be able to access this outside of the class. Two, it's static. That means the instance variable that we call instance is going to be accessed at the class level, not the instance level. We're going to access this variable through the game manager class, not through an instance that we're creating. Okay. This is a reference to a game manager type. Okay. So we're inside the same class. We're inside the game manager class, and we are referencing another game manager object, okay, which is going to be what we call instance, because there's only going to be one. Private void start. This gets called right at the beginning. Start gets called right at the beginning. And in fact, I like to make my instances in awake. Okay. Awake is the same thing as start. It gets called once right at the beginning, but awake gets called before start. Take that for what it's worth. Awake happens first, then start. So awake gets called on all the objects, then start gets called on all the objects. And what we're going to do here is we're going to learn how to spell. Check to see if the singleton exists already. So the way we do that is we say if instance equals null. If instance is null, which it will be the very first time this is run, that means we haven't created the singleton yet. And we're going to create the singleton. We'll say create singleton by assigning it to this game object. So we'll say instance equals this. All right, so let's think about what that code is doing. Big picture wise, here's what I need you to understand. In Unity, scripts get attached to game objects, which is exactly what we have here. We have a game manager game object that exists in this scene. We have attached to that game object a script called game manager. When this game object loads in memory, so when the scene gets loaded, when I click play, the game manager gets loaded, the script on it is going to fire its awake method. We first check to see if instance is null. If it's null, then we are going to set it to this particular reference, which is this script that's attached to this game object. Does that make sense? Okay. The second thing that we are going to do is we are going to say, don't destroy on load game object. We'll say this prevents this game object from getting destroyed when we change scenes. Okay, now we talked about scenes already. Scenes are essentially sections of your game. There's like a title screen, you have your gameplay screen, that sort of thing. Oftentimes what is done is we create these singletons right at the very beginning, right at the startup, which we've talked about before as well, like in a splash screen scene where you're like loading the titles and that sort of stuff. When you go from one scene to another in Unity, all of the game objects in the scene get destroyed, except those that are flagged don't destroy on load. Right? So what we are doing here is we say, if the instance does not exist yet, we're going to create it, and the game object that this script is attached to, we never want it destroyed. Okay, good so far. Now, if, okay, so we're going to say the singleton exists already, destroy this game object. So think about it this way. Let's say we have two different scenes in the game, and both scenes contain a game manager object that has a game manager script on it. When this first runs in the first scene, what's going to happen is instance is going to be null. And so we're going to set instance to reference this script. And we're going to say, don't destroy the game object that this script is attached to, which specifically is this guy right here. Don't destroy this guy. When we transition from that scene to the other scene, the awake function on the second game manager script is going to fire. Instance at that point has already been set to reference the first script. And so we're going to go to this else statement. And what we want is we want to destroy the game object that's attached to the second script. This is how we ensure that only one instance ever exists, which is we've essentially at this point created the singleton design pattern. Okay. All right, so I'm going to do some print statements just so you guys can see what's happening. Okay, so we'll say singleton does not exist. Setting singleton to game object. Game object dot name. Okay, game object references the game object that this script is attached to. Okay. Now, if we get down here, we're going to say singleton already exists. Deleting game object name. Yes, I would use this for anytime you only want one of something, like you have an overarching manager, which is what I'm getting to in just a second, you're going to want to use this setup. You can, player manager is fine. If you only have one player manager, that is a good setup. So here's what I'm going to do. Let me go back to this. So we have game manager, and I want to show you how this looks. I'm going to duplicate this. I'm going to call this second game manager. Notice that both of these game managers have this game manager script on them. Okay, which means the awake function for both of these scripts are going to fire separately, one after another. And the first time we expect, okay, the instance hasn't been created yet. Let's go ahead and create it. Say, don't destroy unload the game object. And then we're going to just do a print statement to let it know what it is. But when we hit the second one, then we're going to say, well, it already exists. We want to delete it. All right, so let me run this. Notice we have game manager and second game manager. So I hit run. And here's what we get. So I'm going to go back to normal view and let's look at this. So shrink this a little bit. Singleton does not exist. Setting singleton to game object, second game manager. Singleton already exists. Deleting game object, game manager. So we could see the one below, the second game manager actually ran first, and that became our singleton. And we deleted the other one. So look over here in the hierarchy. Okay, I've paused the game, like the game is still running. But notice what happened. We created a second section called Don't Destroy Unload, and we moved the second game manager down into this part. So that means this is now included in the Don't Destroy Unload stuff. So when we transition scenes, this isn't going to go away. But what happened to our other game manager script? Well, it got destroyed. We deleted it, which is exactly what we want to do. And so we have now forced a single instance to exist through the code that we wrote. Okay, so any questions on what we've done? All right, so I'm going to come back here and I'm going to delete the second game manager because we only want one. And I understand that we haven't gotten to the part where we see why singletons are beneficial. We will in just a second, I promise. Okay, so what we can do now is, so we can use this design pattern for other things. Like we could make the player script a singleton. We could make the enemy or the bad guy a singleton. We could also simply create references to those on our game manager script. And that's what we'll do here. So I'm going to say public player manager, call it player. I'll say public bad guy manager, we'll call it bad guy. Okay. So go to game manager, and now we have spots where we can store references to the player and the bad guy. Okay. So that leads us back to the original problem we had, where we wanted to set the bad guy's initial position based off of where the player is. So here's what we're going to do. So we'll say set bad guy's initial position to be ahead of and to the right of the player. So we're going to say vector 3 player position equals. Now, I want to get access to the player's position, and here's where the singleton comes into play. We're going to say game manager dot instance dot player dot player transform dot position. That's a lot, but we have access to the player manager, and inside the player manager script, we have access to the player's transform. Okay, and so now we can access that through the game manager. We'll say starting offset equals new vector3, and we'll put it 5 units to the right and 5 units farther down. Okay, so we'll say trans.position equals player position plus starting offset. So again, we're in our bad guy manager script, and so we're gonna set the bad guy to be farther down that way. So I'm gonna take the bad guy and just move him behind the player. Oh, we actually want to do 0.5 because he's offset by half. So when we click play, why is he floating above the ground? Oh, all right. See if you guys can figure out why he's floating above the ground. That's right. We're adding to the player transform. Yes. So because the player's the player's position is already at 0.5, when we added another 0.5, it just moved it up to 1, which is why it's at 1. We don't want it at 1. We want it at 0. And so we'll just leave the amount we are adding on at 0. Okay. All right. So good. Any questions on this so far? Okay. Now, a lot of times in your game, and this is where we're getting to the next part of this topic outline, which is vector subtraction. It is most often used to get the direction and distance from one object to another. The order matters. Subtraction, is not commutative. You can't just switch the two numbers and get the same answer. 5 minus 3 is not the same thing as 3 minus 5. And so the order in which we subtract these two things is going to have a pretty important impact on what we get. So many times in game development, we are going to want to get a line or the vector between these two things. The reason we need a vector between these two things is so that we can have one object pursue towards another. Okay. Let's say, for example, we wanted the enemy to shoot something at the player. Well, we need that vector to shoot along. All right. If we wanted the player or the bad guy to face the player, we would need that vector so the bad guy could face that direction. All right. So what I'm going to do is I'm going to do some pretty sweet artwork for me. I need to know which way is forward. All right. This way is forward. So I'm going to right click on this and go create sphere. I had to think what a circle was for a second. This is way too big. 0.25. 0.25. 0.25. Let's go 0.2, 0.2, 0.5. Okay. Left eye. In Unity, if you highlight an object and hit Control D for duplicate, it will duplicate the object. We're going to call this right eye. We're going to move it over to negative 0.2. All right. And then let's give him a nose. Whoop. All right. Let's rotate it. that would be the X rotation. So we'll go 90 degrees this way. This is way too big, 0.25, 0.25. I feel like you guys are judging me right now. Now you're just laughing at me. All right, so there's our artwork. Okay. Nose. All right, so this is our enemy, our bad guy. We can see him. The game starts and he's like, I don't care about the player. I'm staring off in the opposite direction. All right, what we want is we want for the bad guy to actually look at the player. And so this is what we'll finish up with today. We're going to have him turn and face the player. Okay, so here's what we're going to do. Private void update. Update gets called basically as often as it can, like every frame. And so we're going to say face the player. In fact, I'm going to call a method. We'll say face player. Private void face player. Thank you, Aiden. All right. Face player. So the very first thing that we're going to do when we want him to face the player is we need to get the vector, calculate the vector between where he is and where the player is. The way that we do that is by subtracting the two positions. And this is where the position manipulation comes into play. So we're going to calculate vector from bad guy to player by subtracting their positions. Okay, so we'll call this vector 3 towards player. Now, the way we do this is we're going to subtract the player's position from the bad guy's position. So we'll say game manager dot instance dot player transform dot position minus trans dot position. Okay, this is the player's position. This is the bad guy's position. So we're going to subtract the two. And when we subtract the two, we now have a vector between the two. Does anybody know what the length of a vector is called?
It's magnitude.
That is correct. It's magnitude. And so what we can actually do is we can print out the distance by taking towards player and saying magnitude. That'll give us the distance of the vector between the two players. Okay, we don't need it in this situation, but it is helpful at times. Now, sometimes we will need exactly how long that vector is, and sometimes we don't. In this situation, our goal is to simply face the player. And because our goal is to face the player, we don't really care about how far away the player is. Whether the player is 1 unit or 1,000 units, the bad guy is still going to face the same direction. So in this situation, we are interested more in the direction rather than the magnitude. Okay. And when you're interested in the direction, then you can do what is called normalizing the vector. When you normalize it, that means you shrink its length to 1. So it has a magnitude of 1, and you can do some different things with it. But we'll talk about that in a minute. What we need to do is we want to change the bad guy's rotation to have him face along the vector. And there's an easy way to do that. And this is getting into a little bit of the rotation manipulation, but we'll kind of combine that. We're transitioning into that right now anyway. So let's do it like this. Let's do, let me show you guys this code. Quaternions. Have you guys heard of that term? Quaternion.
I've heard of it, but I'm still kind of lost as to what it means.
It's
Something
kind
to
of
do with
like a,
rotation?
it's kind of like a different way of doing coordinates to avoid gimbal lock, right?
Isn't
Yes.
it just a vector 3, but for rotation?
Close. So quaternions are 4-part rotations, hence the quaternion part. We are used to looking at rotations in 3 parts, which is an X rotation, a Y rotation, and a Z rotation. Quaternions have a 4th component. And full disclosure, I don't know enough math to understand how they work. Okay. We're talking like high level graduate math doing quaternion stuff, and it's way over my head. I don't get it. It involves, I sat down one night about, I don't know, 8 years ago, and I'm like, I want to learn how quaternions work. It lasted about 45 minutes. Or like, remember when you did the imaginary numbers? Like you guys remember doing that in math? That's when it lost me. It's really complicated. Luckily for all of us, Unity has a way to abstract how to interact with them, which is a good thing. But you do need to know it. So here's where it gets really, really confusing. When you look at the rotation of an object inside of the inspector, so we have transform, we talked about position a good bit. Rotation, we see 3 parts, X, Y, and Z. Okay, so wrong button. So we would think that if we are going to say trans dot rotation, so we know we can do trans dot position to change the position of the transform. We can also do trans dot rotation. Okay, and we would assume that the rotation property, because we see it here as X, Y, Z, we would assume that the rotation property is also a vector 3, but it's not. It's a quaternion. Okay. And a quaternion has 4 parts to it. So you can't simply say, well, set the X rotation to this, the Y rotation to this, and the Z rotation to this. It doesn't work that way. You have to use a quaternion. However, there are some easy ways to do that. Now, Susie, you did mention, isn't that similar to just how we represent rotations? Kind of. The way that we are going to use XYZ rotations are actually something called Euler angles, which is spelled like that. I think the guy was French who came up with them, but we'll get into that later. Long story short, because we're running a little low on time, here's how this works. So I'm going to show you the code and then I'll explain it. We're going to set the rotation using the vector that we calculated, which is from the player, or excuse me, from the bad guy to the player. There's a built-in function called look rotation, and it is in the quaternion class. So we're going to say quaternion dot look rotation. Okay. And as our IntelliSense shows us, it says creates a rotation with the specified forward and upward direction. Okay. So essentially what this does is it takes a vector pointing in a direction and it'll give us the rotation needed to match that vector, which is super helpful. Luckily for us, we already have the vector, which is the line going to the player. So we're simply going to say quaternion dot look rotation towards the player. And that is going to give us, that's going to return to us the quaternion necessary to face that direction. And that's it. That's all the code that we need. Okay. We save it and run it, and we'll see what we get. We magically have our hideous, very terrifying bad guy facing directly to the player. Okay. Now, are you ready for this? What happens when we move? Oh, oh, oh. He's following us. You are going to have nightmares about this. You're going to wake up and that cube is just going to be sitting in your room looking at you. Okay. Now, the reason you should be, the reason this is working is because we have it inside of update. All right. So the code for rotating the bad guy. Yeah, that's true. The code for rotating the bad guy is inside of update. So it's running constantly. All right. We go with this stuff. There's some deep lore between the red guy and the brick sphere. Yeah. All right. So questions on this?
So, I mean, I assume it would be pretty simple process to say you're some distance away from the bad guy can't see you. When you get into like that little like radius of detection, like he's able to like turn around and spot you, maybe follow you. You leave the circle of detection, like in the radius of the bad guy. He like stops looking at you.
Yep.
I mean, that's obviously can be done, but like how could you show us how to do that perhaps? Or would that take a little while?
See if this works.
Okay.
Oh, that scared me. So he's like staring off to space. So as soon as you get close enough, he just. That is terrifying.
Mm.
So all the code is this. So if the magnitude, which is the length of the vector, is less than 5, I just picked an arbitrary number, then he'll look at you. Otherwise, he'll stare off into space. Quaternion.identity is 0, 0, 0, 0, 0. Okay, he'll just look up, it's here. So something like that is fine. So he's constantly checking the distance, and you can use the different distance formula if you want. But this is how it works.
And one thing, so if I'm going off topic a little bit, one thing I had trouble with last semester was like getting rotation to like smooth out. It looks like he's just kind of like immediately like popping like right towards the player. It does. So what would be the best way, or the easiest way, because we're all new here, to smooth out like a rotation, but to gradually look towards the player as opposed to like immediately like jerking 90 degrees.
In the interest of time, I'm just going to do it. I don't know if that's fast enough. Let me see if that works, then I'll explain it.
Okay.
Is that what you wanted?
Yeah. So yeah, exactly. I've tried to use lit before for that exact purpose. I've never got it to work correctly. What is it that you did
Magic.
besides that?
The code doesn't actually do anything. I sprinkled fairy dust on my computer. You guys can't see it because it's below the thing. All right, so
Got
real
it.
quick, I'll explain what this is. First of all, I was planning on doing this next class, but you asked, so I'll do it now. We added a rotation speed, which is very similar to a movement speed like we did last time. So we're going to rotate at 5. Again, I pick an arbitrary number. Now, if the player is close enough to the bad guy, then what we are going to do is we're going to declare a new variable. So this is a quaternion. Again, it's just think of a quaternion as some rotation. And we set it equal to look rotation dot towards player. So this is the actual rotation that we want him to look at. Okay. Then we're going to use lerp. And so we're setting his rotation equal to what lerp returns. Remember, lerp is a linear interpolation. It's you have point A, point B, and we're giving some point between the two. All right. And so point A, starting point, is the bad guy's current rotation. Point B, which is the goal, the ending point, is the target rotation. This is, again, where we want him to face. So somewhere between where he's currently facing and where we want him to face is what we're going to return here. And we return, like the position is rotation speed times time.delta time. We talked about whenever we're using lerp, whenever we're moving stuff like this inside of update, we need to multiply by time.delta time. This is the amount of time it took for the last frame to execute. This is what's going to give us consistent movement across different frame rates. Okay, and that's it. So we simply lerp the rotation. So we take current facing rotation and then the direction towards the player, and we slowly lerp towards that position. And that's it. And the only difference is if we're not close enough, then we are going to lerp towards 0, 0, 0, 0, which is looking off into space. Okay. That's it.
Thank you. Please tell me this is recorded because I need this.
It is recorded. Just screenshot this.
Okay, good.
But yeah, it's recorded.
yeah.
I'll put this up here. Yeah. Questions for me? All right. So we'll talk about slurp next time, and I'll show you an example from Access Football where I use slurp. So let's stop here for today. We'll pick up back with this on Tuesday, and I'll show you some additional stuff with this and rotation manipulation. And I'm going to reorganize the way the Canvas modules are stored so that this makes a little bit more sense. But yeah, good class. Have a good weekend. I'll see you guys on Tuesday. Don't forget your homework assignment tomorrow night. Do it. It's a good idea.
Thank you. Have a good day.
Well, thank you so much.
You're welcome. See
Thank
guys.
you.
Thank you.
Thank you and have a good weekend.
Thank you. You too.
Thank you.
I'm gonna go.